Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to talk about this idea of how let's say you have a coordinate vector with respect to a certain basis. So here is given by this notation. Okay, and this is something that I have already covered in the previous video. How can you find this coordinate vector with respect to a certain basis? Now let's say you have this result here and you would like to find what is this coordinate vector with respect to another basis. So we call it B prime. So B prime is another basis in that same vector space here, and you are looking to find what is the coordinate vector with respect to this new basis, and hence the title of this slide here is the change of basis. And to start off our discussion, we are going to consider a simple problem of, let's say, having a vector space with only dimension 2. And here we're going to discuss the procedure. How can you change it from coordinates relative to one basis, for example, relative to basis B, and change it to coordinate relative to another basis. So we call it B prime, okay? Right, as a definition, so here is the definition. We have two different bases. The first one here is B, and this is B prime. And notice a slight difference in the terms of notation here. We have V1, but here is V1 prime, just to show there's a difference between these two items here, all right? And suppose we have a vector, so vector V here, and you want to find the coordinates of V relative to B. And this idea or this problem has again already discussed in the previous video. So based on the answer to that, let's say the answer to coordinates of V relative to B is given by these values here. So we have x1 and x2 to denote the coordinates of this vector relative to B. Okay, B. And this is the same thing as saying we have a combination of vector 1 and vector 2. So here is the combination of vector 1, vector 2 here comes from this basis. So you are looking for the combination of this, the linear combination of these two vectors from this basis. Here is a sort of scalar. So here is scalar. And the result that we have in this notation here is the same as this one. So you're saying that vector V, this vector here, is a combination of V1, V2, which comes from this basis. You have a linear combination of it with scalar right next to vector 1 and vector 2. So that is already discussed again in the previous video. Now, the question here is, how can you determine coordinates of V relative to a new basis? So in a simple notation, you want to know what is the coordinate of V with respect to the new basis here. So in order to answer this question, the first step that you need to consider is this one. So this is step 1. You need to be able to write vector 1 and vector 2. So vector 1, vector 2, let me just use the same color. So vector 1, vector 2 here, vector 1 and vector 2 comes from this. Alright, vector 1, vector 2 come from this basis. You need to be able to write them in terms of combination of V1 and V2 from this guy here, the new basis. Okay, we're going to find this V1 prime, V2 prime from this new basis. Again, there is also a linear combination of v1 and v2 here from this basis, okay, new basis. Therefore, to write a linear combination of those, again, of course, we need to know this value here is just scalar, so you need to find what are those. And also this one is also scalar, and you need to find what are those values. So I hope you can see that the idea in step 1 is to be able to write the vectors here from the old basis. Okay, so here I'm just going to write down here is this is the old basis, and you have to write that in terms of linear combination of new basis, okay, so that's the idea. Okay, I'm just going to erase so that you can see the things clearly. Okay, so that's the idea. That is step 1. Therefore, well, what we have here is this is step 2. So in step 2, you can see that what is this thing? Okay, so I'm just going to explain to you what is this thing. So this one here comes from this guy. So from this equation, so notice that in this equation, we have vector 1, vector 2 from this old basis. But now, since we have written vector 1 and vector 2 in the new linear combination of new basis here, we can just replace. Okay, so here comes from vector 1, vector is equal to x1 vector 1 plus x2 vector 2. So where does this come from? This comes from this part here. Okay, now what we have now is we are just going to replace this one here inside vector 1, because this is about vector 1, and the whole thing here is inside vector 2, and that's why we get this part right here. So we just replace vector 1 with this thing, which is a1 v1 prime plus a2 v2 prime. Got it? Yeah, and then based on that, you can simplify. Okay, so how to simplify that? Now let me just erase this. So to simplify that, based on this, you can see we can write down x1 a1 vector 1 prime plus x1 a2 vector 2 prime, okay, plus x2 b1 vector 1 prime. So I'm just simplifying from this part, yeah, and then x2 b2 vector 2 prime, and based on that we can separate them according to vectors from the new basis. So we're going to group v1 together, and so the result is going to be x1 a1 plus x2 b1. This is the new vector. Okay, vector 1 from the new basis, vector 1 prime, this one, and then this part here we're going to group them together. So because we have vector 2 prime here, so it will be x1 a2 plus x2 b2 vector 2 prime, and this is the result that you have here given here. Okay, so that is step 2. You can see that after you have changed vector 1 and vector 2 into the linear combination of the new basis, that means you can write this old equation here with the new one. So you replace the old one here with the new vectors from the new basis. Okay, next is, based on that, the coordinates of v relative to basis b prime are given by this expression here. Now why is that so? Remember that well, in this example here, this is the coordinates of vector v relative to basis b. So this is the coordinates, because v1 and v2 are vectors from the basis. So this one becomes the coordinates, yeah? With the same idea, we can see that, I'm just going to erase this so that you can see. So based on that, you can see the coordinates of vector v relative to the new basis is this guy, this one and this one. So this is the first position, this is the second position. We follow the same idea. So here is just x1 and x2. So x1 next to vector 1, x2 next to vector 2. But right now we have the new vector 1, the new vector 2 from the new basis. So here is the coordinates, and therefore this is what we can write down. The coordinates of v relative to the new basis b prime is just this whole thing here, which comes from this part straight away, okay? So that's the explanation. And then what we can do is this process here, this process here can be written as, so the whole thing here, you can separate them and write it in this way, this whole thing, okay? So you can see that by multiplying, so here is 2 by 2 matrix, this is 2 by 1, so the result is 2 by 1. So here is 2 by 1 matrix, okay? So a1 times x1, so a1 times x1 plus b1 times x2, here is the thing that you get, x1 a1, x2 b1, a1 x1, b1 x2, so x2 b1 doesn't matter, okay? And this one here, a2 x1, so here is a2 x1, b2 x2, so plus x2 b2, so this is the second position. And so this is just rewriting this part to get this. Now why we are doing that? Because we can then understand that in order to find the coordinate vector relative to the new basis, you can consider this matrix multiply with this one. This is the old one, the coordinate vector with respect to the old basis. So x1 x2 here comes from the old one, the old coordinate vector relative to b. Yes, you can see that. So that is the formula, and here we can call this the transition matrix, the transition matrix from the old one to the new one. And sometimes they use this notation to denote the transition matrix from the old one to the new one, so in this direction, okay? So something like that. So that's the idea. It might look complicated right now, but I think with examples you'll be able to see how the process is going to look like, okay? So that's what we're going to do right now. We're just going to jump straight into the example here. Well, in this example, we have two bases, so b and b prime, and you are asked to find the transition matrix from b to b prime. So you can think of it as the old basis to the new basis. So this is the new one, okay? Well, the starting point is, of course, to consider the first step of writing. Okay, first of all, do identify that in this case, this is vector 1, this is vector 2, and this is the new one, vector 1. Okay, we can use this notation to follow the notation given here so that you can see clearly the formula and the action that we have to do. So the first step is to be able to write vector 1 here in terms of linear combination of these two items. And for that purpose, I'm going to call it a1 for the scalar next to this vector. So a1 2, negative 1 comes from here, plus another scalar that we need to find with vector 2 here. So negative 1, 1, and it must be equal to this first vector from the old basis, okay? So here is 1, 1. So notice that this is, I'm just going to give a little bit of notation or information here. So this is the first vector. Combination of, so this vector here from the old one is a combination of new vectors, both of them, from the new basis, okay? So that's the first thing. Second thing is, of course, we need to continue with this guy must be written in terms of combination of these two. So follow the same idea, and we're just going to call it B1 for the scalar next to this guy. So 2, negative 1, plus B2, negative 1 and 1 must be equal to this old vector here. So 1 and negative 1. And this is the first step that you have to do according to, according to this step 1 here. Okay, step 1 here. Alright, I'm just going to call this equation 2, and the above here is equation 1. So we only have two equations because right here we only have two vectors in this basis, okay? Now, how do we solve A1 and A2? Okay, so based on that, I'm just going to say from equation 1, the whole thing here can actually be written in terms of 2, negative 1, and then here we have negative 1, 1. So negative 1, 1, and here is A1, A2. So this is another way of writing the equation that we have here. And that is equal to 1, 1. Okay? And how do we find the unknown values of A1 and A2? Well, we can find those values by considering the augmented matrix. 2, negative 1, negative 1, 1, 1 and 1. So this is the augmented matrix. And what I can do next is I need to turn this value into 1. So I can consider R1 plus 1 R2. So here will be 2 minus 1 is 1, negative 1 plus 1 is 0, 1 plus 1 is 2. So the second row is unchanged. Just going to write down this. Next, what I can do is I can turn this value to be 0. So I can consider this process R2 plus R1. So 1, 0, 2. Negative 1 plus 1 is 0, 1 plus 0 is 1, 1 plus 2 is 3. Well, based on that, I can clearly see that. So here, remember, here is A1 and A2. So based on that, I know A2 is equal to 3. And then A1 is equal to 2. So I got the answer straight away. Okay. Now, next is from this equation, okay, I need to find the values of B1 and B2. So from equation 2, again, if we can follow this idea, which means that I have 2, negative 1, negative 1, 1. Here is B1 and B2 must be equal to 1, negative 1. So here is the new vector 1, negative 1. This is the matrix B1 and B2, okay? And how do we solve for B1 and B2? Well, you can consider the augmented matrix. Okay, and again, we apply the same elementary row operations. For example, R1 plus 1 R2. That will reduce this part here, the first row, to be, this is 1, this is 0. So 1 minus 1 is 0. Second row remain unchanged. Sorry, 1, negative 1. Next, what I can do is I can turn this value to be 0. So R2 plus 1, R1, 1 0 0, negative 1 1 0, 1 0 1, negative 1 0, negative 1. Well, based on this simplified form of the augmented matrix, I can see that, so here is B1 and B2. So the value of B2 is negative 1 and the value of B1 is 0. We can just get the answer straight away from these two equations here. Okay. Now, what is A1, A2, B1, and B2? Well, if you look at this part here, okay, I'm just going to erase this so that you can see it clearly. I'm going to erase this, okay? Well, you can see that here is A1 and A2 corresponds to the line of vector 1, so A1 and A2. You can see that in the matrix given here, the position is at this one, A1 and A2, so it goes downwards. Okay, so if we go back to what we have solved here, so here we have A1 and A2 with respect to, here we have vector 1. Therefore, the result of A1 and A2 have to be in the transition matrix. So here is a transition matrix. It will be on the first row. Okay, so therefore, the question is asking for the values of transition matrix. And based on that, here is A1 and A2. So the order has to be in this way. So therefore, so let me just write down this. Okay, maybe just, sorry. Therefore, the transition matrix is going to be written like this. A1 2, A2 3, so 2 and 3 on this side here. We follow the idea given in this procedure. You see A1 and A2 comes directly from A1 and A2 from the first vector, vector 1 here, okay? Now, if we look at this part here, B1 and B2 is related to the second vector from the old basis. So B1 and B2 here, in terms of transition matrix, the position here would be at this position. Okay, so therefore this is B1, this is B2, and this is the old vector from the old basis. Okay, let me just write down here. So here is actually vector 2 from the old basis. B1 and B2, the result that we get, therefore the result that we get, B1 and B2 will be 0, negative 1. So in this position, so that is the transition matrix that you should come up with. So that is the answer to the first question here. Okay, now since we have obtained the transition matrix, we can then find, okay, I'm just going to erase this. Okay, so I've got this space already cleaned up, just the right part here, so it doesn't matter. I'm just going to use this space. So now since we have got the transition matrix, we can then find the coordinate vector with respect or relative to the new basis, and that is equal to having the transition matrix multiplied with coordinate vector from the old basis. The old basis, the transition matrix, will give you the new one, coordinate vector relative to the new one. And again, transition matrix sometimes are denoted as this symbol. You can use this symbol as well, from B to B prime times vector B. Sorry, let me just make sure that looks presentable a bit. So here, okay. And the transition matrix is just this guy. We have already obtained the value here, which is 2, 0, 3, negative 1. And what is the coordinate vector relative to basis B? So coordinate vector relative to basis B is given straight away here, so we can just apply the values 3, negative 2. And this is again 2 by 2 matrix, 2 by 1 matrix. You will get 2 by 1 matrix here. Well, to find the values, row and column, you multiply them. So 2 times 3, 6. 6 plus 0 times negative 2 is 0. So here is 6. Next, this guy and this guy. So 3 times 3, 9. 9 plus 2 is 11. So 6 and 11. Alright, so that's the idea. An example to illustrate to you guys how you can change the coordinate relative from one basis to another. And of course, what we have discussed is a simple problem where you have dimension 2. Now, here is a theorem that extends this idea to have perhaps dimension n, more than 2 vectors in the particular basis. You can see here we have a lot of vectors in this basis up to n, and here is also a lot of vectors up to n again. And the transition matrix, we're just going to carry the process further. For example, we already have this part here. Sorry, in order to find the transition matrix, remember to consider the first column. The first column here is considered when you consider okay, based on this, when you consider the scalar related to the first vector, so you put it in the first column, right? And then if you have the scalar from the second vector here, it will be in the second column. So here, first column, second column. So the same idea is given here. So here we contain the scalars from the related to the second vector, and then it will continue on in this way. So it might be the last one for the last vector. Okay, so that's the idea. And if you want to find the coordinates vector relative to the new basis, we're just going to take this transition matrix here with big numbers, because we have many dimension, n dimension, and you multiply that with the old one, coordinate vector relative to the old basis. So it is the same idea really, and I think this idea here will be better understood if we look at an example, and I think the example here will be given in the next video, because I think this is already long enough. And thank you very much for watching. I'll see you in the next video.